Okay? So if we follow the process, or the first thing I usually get people going through and doing is that we say 325 milligrams, I want to go to grams. Well, that just means I shift the decimal point, so I'm just going to shift the decimal point, and I get 0.325 grams.
I mean, if you want to make it that easy.
I'm going to argue this isn't a question of easy. What was your process?
Do it your way. Well,
You just memorized how to solve it, and you just created an algorithm that allows you to do that. Okay? With something this simple, yeah, fine. An algorithm makes sense. I don't care that this is a simple problem. What I want is not that you're getting the right answer. I want the process behind it. What was your process there? I just wrote down a bunch of numbers and said, well, this is what I do in my head. That's not a process. Okay? As soon as we change it to a system that you don't know, you don't have something in your brain to use or grab a hold of, your process falls apart and you can't solve the question anymore. Okay? So, did I do that right? Yes. Yeah? Yeah. Okay. So that's how bad I am at doing things in my head. I have to write them out, just for the record. Okay? So it's not that that's wrong, it's that the process behind it is bad. You don't have a solid process. Okay? What I want you to focus on is the process behind it. So right now, you can do that. And if I ask this question on a test, where it would show up is strictly multiple choice. There's virtually no work to show. Okay? So let's add a layer on this for another approach to it. Okay? We could have gone through, and if we start to follow the process a little bit better to what we suggested, we need to write down first what we're solving for. Well, what are we solving for? Grams. We have to read the question carefully. It says that I want grams. Officially, it's grams of aspirin. But are we changing the substance? No. If the substance doesn't change, we can get lazy and not write the substance. Okay? Not a good idea, because that'll bite us later on, but we could drop it because the substance isn't changing. We could then write down what we're given. 325 milligrams. Okay? The next part we could go through and do is say, well, I want to do a conversion where I need to get rid of milligrams and I need grams. So there are 1,000 milligrams in 1 gram. Okay? Just walking around the room, we got probably half of the classroom doing roughly that calculation. Okay? As an example that I already went through with a couple people, 3 times 2 is
6.
2 times 3. 6. So the order in the multiplication doesn't matter. I don't care which one of these I do first. As long as they're there, I'm good to go. If we track our units, what happens with the units? They cancel out. I get grams, and I get the same correct answer. Okay, that 0.325 grams. So that's all fine and cool. You've mostly followed that process. And in fact, as far as I'm concerned, you have followed the process. I'm going to challenge that what you've written in your conversion here is problematic. Okay? And I'm also going to challenge that what we wrote for 325 milligrams is also a little problematic. Okay? That one's a relatively minor one, so let's look at the 325 first. Okay? So what I would argue is instead of writing 325 milligrams, I should write 325 milligrams, because this is what I'm given, and that information I'm trying to convert across shows up in the numerator. So when I'm solving these, everything I write in must be a fraction. Okay? So what's in the denominator if that's in the numerator? 1. 1 what?
Nothing. It's just
Nothing. Okay? If it's a number, anything other than 1, I wasn't given 325. I was given something else. Okay? If it's any unit other than no unit, then I wasn't given 325 milligrams. I was given the relationship between 325 milligrams and something else. Okay? So what I'm doing is placing that 1 there to make sure I go, don't place anything else in there. Okay? It's locking that position out. This is now a single piece of given information. Okay? That is one set, or one data point, if we will. Okay? And of course, I forgot to write the grams as step 1. Okay? So now the next part is, what is our conversion? Okay? Well, the logic behind this one is that I would look at my given information and my end result. Those are both in units of mass, so everything looks fine. I've got them in numerators. Okay. Does grams equal milligrams? No, those symbols are different, which means in this next step, two things have to happen. Okay, or ideally, two things happen in one single step. It may not happen in a single step, but I want those two things to happen. Number one, what needs to happen to milligrams?
On the bottom.
I want it on the bottom. Okay, so putting it on the bottom is the result of what I want to happen. What do I want to happen to the units of milligrams?
You want it to cancel out and just be left with
I want it to cancel out. And because in my given information, milligrams is in the numerator,
you just put in the denominator.
I know it needs to show up in the denominator or on the bottom. Okay, that's why I'm placing that unit there. You'll notice what number did I write in front? I didn't write one because I don't know what number to put there yet. The numbers are utterly meaningless. The only thing that carries meaning is the unit. Once I know what the unit is, I can place the number. Okay? And we could say, well, now I could put 1,000 in. Really? 1,000 milligrams is 1 nanogram? No. Okay, 1,000 milligrams is 1 milliliter? I don't know. Okay, is that the same thing as an inch? No. Okay. I can't place a number yet because I don't know what I'm relating that milligrams to. If I don't know what I'm relating it to, the number still isn't useful to put in there. Okay, what do I want to have happen?
Converting to grams.
Okay, and I would argue converting to grams is again the broader scale, so I want to get narrower. What do I want to have happen in this conversion?
Find out how many milligrams is in grams.
The milligrams cancel, right?
I want to be left with grams.
I want to be left with grams. So what has to happen in the numerator?
With grams.
I need grams to show up. Okay? So we're boiling this down to not these broader concepts. Oh, I want to convert. No. I know I want grams. So now that I have units in there, I can ask myself, am I responsible for knowing the conversion between grams and milligrams? If the answer is yes, then I have to pull up my memory banks and pull out what the number is. Okay? If the answer is no, I should look at the front of the exam. If I still can't find it on the front of the exam, I should raise my hand and be like, I don't know what this is. And hopefully at that point, you did everything right, and that my response would be, oh yeah, I'm sorry. This is what those things are. Let me write that on the board so everybody has access to it. Okay? If you didn't memorize something that you were supposed to, all I'll end up saying is, sorry, you're supposed to know that. Okay? But you've at least satisfied those conditions. Okay? This is a different focus than what you may have seen in the past, because in the past you focus on dealing with the numbers. The numbers are utterly useless. The biggest complaint I get from students at the end of the semester is I don't solve anything. Hell yeah, I do. I just don't care what the numbers are. I set up the units to go through and solve it. Once the units are there, I can solve. What happens? Milligrams cancel. I'd be left with grams. It's solved. Do I know what the number is? Okay. I don't really care at this stage. All I care about is that process. Okay. If it's a multiple choice answer, do you need to go through and do all this work?
No.
You didn't have to do it. You could have done it in your head. Okay? At this stage, what I want is that work. That's what I want to see. At a later stage, we'll bring in the numbers. But we'll bring in the numbers in a situation where you can't do it in your head. Okay? So then I'll be looking for the work and the calculation. Okay? Can I punch buttons on a calculator? Okay? So let's take this to the next initial step behind this. We have grams to milligrams here. What are the numbers that should go into that? Okay, and we could cheat and just use the information in blue right above.
1 gram over 1,000 milligrams.
We could go through and say 1 gram, 1,000 milligrams. Milli means 10 to the negative 3. Is 1,000 10 to the negative 3? No. Okay. The argument that I'm going to make here is that if you memorize that 1 gram is 1,000 milligrams, you have memorized more information than I had to. Because what I'm going to suggest that you need to memorize is that milli means 10 to the negative 3. The power of 10 in these kind of conversions will always go in one particular place. It will always go with the core unit. Which is the core unit, grams or milligrams? Grams. I need to place 10 to the negative 3 here. What goes in front of milligrams? 1. Said another way, 10 to the negative 3 means milli. So let's do a substitution. 10 to the negative 3 means milli. Is a milligram equal to a milligram? Yes. Yeah, there it is. It directly solves out of the system, and I can see that direct translation. Okay, 10 to the negative 3. I asked this question earlier on about centigrams or centimeters, I think. Okay, and nobody volunteered out the 100 option. You guys have now volunteered out the 1,000 option. Why did you bother to memorize 1,000 milligrams in 1 gram? Because you were told to memorize that from somebody older. Okay? Why were they memorizing that? They were told by somebody further down and further back, until ultimately it goes all the way back to a person that said, well, I don't like powers of 10, and I don't like negative powers of 10. And because I don't have any fancy devices to be able to do this, I'm going to convert that negative power of 10 into a number I can manipulate a little bit easier with my puny human brain, and I'm going to turn it into 1,000. By doing so, I have to change the location of where that number is. To do that, I have to know the meaning of grams and milligrams. So I have to memorize the number and that meaning between them. Okay? We don't have to do that anymore because we have advanced technologically. And what do we now have? Calculators that'll do the negative power of 10 for us. We don't have to stress about it. We can use a calculator to take care of it for us. That does mean we have to use the calculator. Okay? And so if you decide to not use the calculator, then you need to use the old school methods, and that's fine. Okay? That means you have to memorize 2 pieces of information. What is the power of 10, and what is the relationship between milligram and gram? You might say, well, no, I don't really have to do that. Okay, well, here's an example of why you would have to do that. Because if you go through and look at this, you're saying that we should get 1 gram is 1,000 milligrams. So you're placing your power of 10 with milli. What is your conversion between kilograms and grams? Ten to the power of 3. 1,000 grams is a kilogram. Where did your power of 10 get placed?
The bottom.
Not in the bottom, because remember, these are arbitrary. We could flip those any way we want. Where did the power of 10 get placed? With the gram, with the core unit. Where did your power of 10 with the milligram get placed? With milligram. You're placing your power of 10 in a different unit location. You have to memorize the power of 10 and the meaning to be able to place the power of 10 correctly in your conversion. Okay? It is an insanely subtle thing. Okay? But it is such a major thing that one of the most common answers you'll hear described in the tutoring center is, well, which is bigger, kilograms or grams? Well, if I freaking knew that question, I wouldn't have screwed up the conversion factor to begin with. Okay? And what's ultimately happened is that we've pushed this power of 10 memorizing more information instead of just using the tools that we have at hand. Okay? Insanely subtle difference, but that subtle difference on a test can make you swap placing the power of 10 in the wrong place, and you would end up writing for kilograms, 1,000 kilograms is 1 gram. No, it is not. Okay? The process that I'm telling you to do is place your power of 10 always with the core unit. Now all you have to memorize is that a lowercase m means that power of 10. That a capital K means 10 to the third. Okay? You have to memorize one piece of information. Okay? The other method with this thousands, okay, requires you to memorize not only the power of 10, but also the meaning of those units. You now have to memorize twice as much information as me. Your brain that good? Fantastic. That's awesome. Go for it. Okay, but when you screw it up on the test, you likely will. All I will do is point at it and be like, remember how I told you to not do this? This is why you screwed it up. Okay? And that's okay. That happens. We all make mistakes. I just want you to make the mistakes not on the exam. Does that make sense?
So maybe to provide some history here on one screen. So one of the reasons why, going back to the thousands, using the 1,000 versus the 10 to the negative 3 or 10 to the 3, if you look, when were some of the bigger numbers added to this system?
More recent.
1960, 1970, 1990 is when some of those things that got beyond kind of the numbers that we are used to using, the thousands and that sort of thing. Like the core system started in the late 1700s. We've got tens, hundreds, thousands. At that point, people are going to be, and if people who are trained in that version of the system, they're more likely to default because those are easy numbers. What Mike's doing is saying we've gotten to a place where the type of science we're doing requires more and more fine-tuned language. And so for this process to be scalable, sometimes it helps to have that historical understanding of why is it that you would default. Well, they did too back then, but when it came to, because the original system only involved 7 units. So, all right, random.
What do you got, Sue?
History of the
And
language.
don't get rid of that yet, just in case Sue has something to say about it.
Okay, so technically, so if we're gonna look at this, okay? So what you're saying is the reason they switched was because it was easier to use that system instead of
It was easier for someone to go through and look at the conversion. All right, let's clean some of that out of there. That if you were to memorize the relationship between grams and milligrams, it was easier to memorize 1 gram is 1,000 milligrams than it was to memorize 10 to the negative 3 grams is 1 milligram.
But if we use it in conversion, it's actually easier to use 10 to the -3.
Absolutely. The 10 to the minus 3 is an easier system to memorize because that power of 10 now always goes with the core unit. So it's not memorization of the number, it's the manipulation of that number in a calculation.
Well, someone finessed us, man.
Yeah.
Someone screwed us.
Okay? And it's not that they screwed you. It's that, is it easy to do a 10 to the negative 3 in your head? No. Okay? So when they didn't have a calculator, maybe 10 to the negative 3.
But
Okay.
even if you get higher, it's like easier, instead of memorizing that entire number, you tend to just move the zeros, or the decimal. It's like easier.
But you still then have to memorize that extra piece. There is another connection that you have to tie to it.
All of that, but not this.
And make sure that they can remove part
Yeah.
of it's also the amount of time it takes to write out all the zeros. If you're dealing with billions, trillions, and sextillions, I don't know
Yeah.
how often it happens.
Yes,
Sextillions.
I think that's right.
It's near the top.
Yeah.
Like, who wants to write 21 zeros?
Yeah.
I'm just saying.
And so we can do some of that manipulation. And it's not that this is wrong. It's not wrong to say 1 gram is 1,000 milligrams. It is absolutely valid and true. The reason we did that is it's easier for the human brain to wrap its head around a positive value. Even if we wrote that out as a power of 10, it is easier for us to deal with 10 to the positive 3 than it is for us to deal with 10 to the negative 3. Negative things always screw you over. Always. Okay? And for those of you being like, I don't know about that, what happens to the charge of an atom that loses an electron?
becomes more bonded.
If it loses something, how did it become positive?
Because opposites attract.
That's a different case though, because we can't.
No, it's not a different case, because there you're dealing with negatives.
Oh, yeah.
It's the same issue. It's that negative symbol. It is the meaning of that negative that the human brain has a hard time tracking and manipulating. Right? That's why we shifted the system into something like this, so that we didn't have to deal with that weird negative thing. Okay? And it's not a huge deal. The issue is just that you now have to memorize not just what the power of 10 is, but then also where to place it in your conversion. And that becomes the challenge. If we stick with the system as I'm telling you to do it, your power of 10 always goes with the core unit. It never changes. I don't have to memorize an extra piece of this is why the 10 goes here, because milligrams is smaller than grams. Okay? I just place it there. Okay? Once I do all my calculations, then I can sit down and look at my numbers and be like, well, what does this actually mean? Not conversion 1, what does this mean? Conversion 2, what does this mean? Conversion 3, what does this mean? Conversion 4, what does this mean? Now I have an answer, what does it mean? I can run all of those calculations kind of blindly and end with a result where now I can focus on what the meaning is and not have to stress about nuanced meanings all the way through the calculation. Okay? Hugely subtle change to how we go through and do these calculations. So when we go through and solve them in class, I will always place the power of 10 with the core unit. Okay? Because I want to demonstrate that. If you don't want to demonstrate that and you want to go based off of what you've memorized, I'm fine with that. Okay? I will balk a little bit, but if you're right, you're right. Okay? So I'll accept it. Does that make sense? Subtle nuances can make big differences. Okay.
This is a writing system, and there's a logic behind it, and there are a couple different ones you could use.
Which brings it kind of an interesting point. There's two different logic systems at play here. There's how old people did it and how young people did it. You're like, well, that's not that big of a difference. You listen to the same music the old people do? Do you drive the same way your grandma does?
Yes.
Wow. Damn.
I drive
That kind of scary. That explains a lot on the roads. Okay? We adapt and we change. Okay? So some of those changes can be good. Some of them are potentially bad. One of the big problems with adapting to this system is, what does it require you manipulate? A calculator. Will you always have a calculator?
Yes. So on your phone. Well, technically, yes.
Probably for your lifetime, yes, you will always have a calculator. The same thing happens with languages. When the first written words came out, people started to notice that what happened to their memory?
It got better.
It got worse. Why did it get worse?
They wrote it down.
They didn't have to memorize it. It was written down. They could open up a book and find the information in the book. Okay? So changes will happen. It's just a question of how we adapt to those changes. And you can fight that change. That's fine. You may very well lose.
Can't you also argue that sometimes the memory did get better? Because if you find somebody really interesting, you can go off and memorize it and tell it to another person.
So
You can memorize one fact, not necessarily thousands.
From a literacy perspective, when words and printed word came into play, when we started writing stuff down, the individual's memory got worse. The culture, the society's memory got better. Does that make sense? The corporate memory grew because we could hang on to information beyond the individual. The individual memory shrunk because we didn't have to hang on to information to keep us from dying all the time.
Connie.
I've just been told not to read and read. It hurts my memory.
I'm going to be a little nitpicky on it, but isn't it, like I was saying, that if you write stuff down, it helps you remember? Because whenever I'm memorizing stuff,
Yes.
I always have to write it down. So wouldn't it make their memory better?
So it depends on if you're the
For
one
the person writing it down.
Because here's what happens.
Oh,
It's
but
a-
the people
so
that are okay.
It's
okay,
a
now I got it.
psychological trick because the person writing it down might say, "Oh, I'm writing this down." And they'll have the visual stimulation of seeing the words on the page to memorize. But most other people will say, "I know I can look this up. I'm not even going to write it down." Who here took notes in my class earlier? Okay. Who here took notes the entire class?
Why,
So,
Exactly.
I can look this up. There, in Mike's stuff, sometimes people won't. I've watched an entire class not take notes because he records all his lectures. He's got all his PowerPoints. It's almost one of those things where he's trying to help you, and so that you can go back and look at it. People go, "I'm going to go back and look at that, and I'll remember it better." And they never go back and look at it, and then they don't remember it the first time. So there's this weird kind of social phenomenon where, yes, if you write down stuff and you focus as you write down, that can be a good mnemonic or good memory technique. But if you make the false assumption, or you say, "I can go look this up, so I don't need to write it down," which is what a lot of people do, then you start seeing that decrease in individual memory.
The fact of
People
us,
trick themselves into not memorizing things.
the fact of us writing it down shows that our memory has decreased because we need to write it down to memorize it.
No, because you have a certain limited capacity in your brain. There's only so much in there, but some people are better at remembering things than others. And
Everything was like, they never wrote it down, it's just like,
Yeah.
oh, like, please memorize this. If people like, here, we've been taking notes since the beginning, so we need to write it down to memorize it.
So you're saying causation and correlation are the same, and we have to be careful because we don't have proof.
And
to say that
there's also a
correlated
practice there.
causes.
There's a practice behind memorizing things where you've trained your brain and your eyes to retain that information and be able to recall it better than just going, "Oh, well, I know I can always go back and read it again." You've actually trained your brain to not memorize it because you're making the statement that you can go back and read it later.
As opposed to something where this is the only person this is the only time this person's going to speak to me right now about this thing, and so I need to pay attention because there's not certain rule or Lady Siri or whatever to go back and check with because this person is a traveling teacher and he only comes around once every 100 years or whatever. 10 years, I don't know. Depending on
Not
the
that old.
empire, they had roads, you could travel a little faster. But that's the idea.
I don't have to write down anything. I can remember
Yeah.
a 6 times order perfectly.
Whereas if you asked me to be a server, I would screw it up every single freaking time.
Or you develop memory practices so that you
Yeah.
could.
Because it's fast, yeah. And I go over there, I don't know. So that's cool. It's
So-
like, God.
Let's push a little bit further because we actually have some content in the chem class that we got to get through. Do you guys want to try and set up another conversion?
Yeah.
Okay, set this one up. This is a little bit different, a little bit trickier. Okay, a little bit trickier because how many of you know what a microgram is? No. Okay, so the symbol for microgram, and it actually depends on who you talk to. The official symbol is this, okay, which is kind of like an italic M if you look at it. Like if it was slanted that way, like I could write Mike. Everybody see that? Okay. Okay. I think that's actually why they call it micro, or where M comes from, because this is the symbol mu from the Greek alphabet. Okay, so it is M, but it's in a different language.
Because my name's Mike, that's why.
I'm a little egotistical. I don't think I'm quite that bad. Okay, so that is our symbol for it. Sometimes you'll see it written as MC grams. Why?
That's on pills.
That's on pills. Why do they write it as MC?
People can read it better for the italicized F.
Most people don't understand the Greek alphabet, and so they write it out as MC. Okay? In this class, we write it out as the mu symbol. The mu symbol means 10 to the negative 6th. Okay? So what are you solving for? The mass in micrograms. So mass is the measurement. The unit that we want is micrograms, so we could write that. What were we given? 325 milligrams. Okay, so this is starting with kind of the basic pattern on how we would go through and solve this. Okay, ideally what would happen in our conversion? Because milligram and microgram are not the same thing.
So we need to convert it to grams first?
Not quite yet, ideally. Okay, and so you're right, but I want to go the ideal system. Ideally, what happens in that line?
You do 10 to the
That's a number. I don't care about the numbers.
No, so milligrams in the denominator.
I want milligrams in the denominator, and I want micrograms on top. Okay? Those are saying, but I don't know that. That's fine. I don't care. Ideally, that's what I want to have happen. Okay?
Erase your G.
Erase my G?
Didn't you say micrograms on top?
Yeah.
Yeah, that's a microgram.
This is another reason why they sometimes put MC. Because it's hard to tell when you're handwriting.
Sorry.
Well, it's because when you put the microgram symbol on the bottom, you just specify the micro.
It was supposed to be a milli on the bottom. So there's milligram and microgram. That would be the ideal circumstance. Do I know that conversion? And Suf, shut your mouth.
Yeah.
Okay? Micro means 10 to the negative 6. The power of 10 would go with the core unit. What would the core unit of micrograms be? Grams. And can't use 10 to the negative 6.
Use 10 to the negative 3.
Okay? I could use the 10 to the negative 3 in reference for milli. So the power of 10 would need to go with the core unit. What is the core unit of milligram? Gram. Do I have gram? Damn it. Okay? So this conversion outright doesn't work right away. Okay? And so now what happens is, what do we do with this? Okay, so the first potential step for this to be, or could be, well, what do I have in common between microgram and milligram? Grams. So I could go through and take 325 milligrams and convert this into not micrograms, but grams. What is the relationship between milligram and gram? 10 to the negative 3. Where does the 10 to the negative 3 go? With grams. What goes in the denominator? 1. This would then get me 325. Oops, sorry, you're right. Grams. Okay. Is grams what I want for an answer? No. So I would set up a new calculation, micrograms, where I'm starting with 0.0325 grams. I need a conversion. Grams needs to go in the denominator. Micrograms needs to go in the numerator. What does micro mean?
10 to the negative 6.
10 to the negative 6. Where does the 10 to the negative 6 go?
No. Denominator.
Our power of 10 always goes in a very particular place. With the core unit. What is the core unit? What is the core unit of micrograms? Grams. So where does the power of 10 go?
Denominator.
With grams. It does not go in the denominator. It does not go in the numerator. Okay? It does not go on top. It does not go on bottom. It goes with grams. Okay? And really you're saying, well, grams is in the denominator. It's in the denominator this time. Okay? It'll always go with the core unit, wherever the core unit is placed. This is why the units are so critical to specify. Because if you start saying, well, it goes in the denominator, guess what happens? You start placing your number in the denominator regardless of where it's supposed to go. It's supposed to go with the core unit. Okay? I could now enter this into the calculator if I wanted to, and I'd get an answer of 325,000 micrograms. Okay? That's cool. That's a two-step process, though, and I would argue we don't need to do that. What kind of mathematical manipulation are we doing in the first step?
We're changing it from milligrams to
Mathematical operation.
Multiplication.
Multiplication and division. What are we doing in the next step? Multiplication and division. Does the order of multiplication and division matter? No. Which means I don't have to split this into two steps. Let's go back up to the top. I want milligrams and micrograms. I don't have that conversion. I could say, stupid eraser, that I want to convert milligrams into grams. What is the conversion or relationship between grams and milligrams? 10 to the negative 3 is milli. Where does the power of 10 go? With the core unit being grams, 10 to the negative 3. What goes in the denominator, or with the milligrams? 1. Okay, what would my unit now be? Grams. Is that what I want for an answer?
No.
What do I have to do? I have to do something else. What's that something else that needs to happen? I don't care about powers of 10. That is a number. I want grams on the bottom. Why? So it cancels that unit. What do I want to show up in the numerator? Why micrograms? That's what we're solving for. And we look at micrograms in our answer. Where does it show up? In the numerator. So on the left-hand side, it had better show up in the numerator. What is the conversion factor between micrograms and grams? 10 to the negative 6 is our power of 10, which goes with the core unit, 10 to the negative 6, 1. In one line, I've done what I did across multiple lines. Well, that's not that big of a difference. That's not that big of a difference with simple powers of 10 conversions. If these aren't powers of 10's conversions, that multiple line system can get really nasty really fast. This is why we set it up in this straight line format across. You'll see that when I go through and do it, you've got it shown as I've got it up there. Okay? In other classes, you may have seen something like this. Okay, with whatever breakups, and then you get whatever you want at the end. Okay? Each of these things is each of these things. Okay, except I shouldn't have put that one in there. Okay, so you might hear the railroad track, which I find weird, but whatever. It's kind of like a railroad track. Okay, I like breaking it up by those individual sections because it helps me see those as units of information. Okay, everything between the beginning and the first operator, that is a single unit of information. Okay. Between the first operator and the second operator, that is a single unit of information. Okay, or a single set of information might be a better word. Okay? I'm not doing multiple pieces of information in one step. Can I? Yes. Okay? I can absolutely smash those together. Okay? The problem with smashing them together is when and why are you doing it? Okay? Are you doing it because you recognize that you can condense those powers of 10? Fine. Go ahead and do that. Okay? Are you doing it because I think I should just smash them together? Don't do it then, because you're missing the cognitive leap on why you're allowed to do it. Okay? So I try to avoid condensing conversions, not because I can't, it's because there's a cognitive leap there that if I start smashing those conversions, you might not track with me. Okay? So try and make sure each of those sections is its own conversion system. And if you've memorized extra conversions, great. Fantastic. More power to you. Okay? You will have to show me where those come from, okay, at some stage, at some point in the future. With the powers of 10, you get a lot of leeway because they're just powers of 10, and some people can deal with that math stuff. Make sense? Okay. So here's our first jump into, it ain't all powers of 10. Not everything is metric. We have the English system. Why? I don't know. Because
we're America, that's why.
There you go. Length. In the English unit, we have 1 inch. Metric is 2.54 centimeters. Okay, so we have to come up with a conversion factor to relate those. Okay, which is going to bring up an interesting potential dilemma.
No. Wait, so did you want us to have all of these memorized, or are you going to get these?
So that's a good starting, easy way into this, because we already get someone going, oh my God, I got to memorize. No, I'll give you these. I do not expect you to memorize these.
Didn't you say that you wanted us to memorize something?
It was the...
Well, I know you wanted us to memorize something.
The millis, the prefixes. Milli, centi, kilo.
Yeah.
We should be fairly easy.
Oh yeah, you just wanted us the physical quantity and the core unit.
Yes. Okay, so let's take a look here. We've got 10 to the negative 3 grams equals
1
milligram. Okay, and maybe Madison's already seeing where this is going.
Don't do this.
How many significant figures in that conversion?
One.
Yeah, one.
Why do you say 1?
Because there's only one digit there, and
Okay. Well, doesn't the first one have 2? I don't have a decimal, so you're going to say, okay, 1. So we would say 1 significant figure. Does anybody want to dispute that?
We are gonna have a decimal if we actually write the whole thing out. It's actually.
So 1.1 milligrams could be a gram?
No.
No. Okay. So is it 1 significant figure?
No.
No.
No solution.
Not quite.
What you taught us doesn't matter anymore.
Nope, I did teach you this. I told you exactly what happens here with the significant figures. How many significant figures in this conversion?
0.
It's infinite. This is a definition. Milli, by definition, means 10 to the negative 3. This is an exact value, which means infinite sig figs. Okay? So cool. Infinite sig figs. Okay? And just because Madison brought it up, we'll have to dress it up here. Let's make a subtle change to it. How many sig figs in the conversion between quarts and milliliters?
It would be, no, if it had the decimal, it would be, has to be controlled by the left and right. So they
If it has the decimal,
it has to be controlled by a significant figure on the left.
where? Just to the left. Decimal point means just to the left. Without a decimal,
Oh,
left
no
and right.
decimal, yeah.
Okay? So I did include a decimal, so how many sig figs in this conversion?
3 on one side, 3 on the other.
So we might say 3. But didn't we just down here say infinite for that conversion? Is this an infinite conversion?
I mean, it should be, but since you put the decimal.
Unfortunately not. When we transition between English and metric, they aren't infinite sig figs. Okay? So I could go through and I can look up another conversion factor saying that 1 quart is 946.3 milliliters.
You just got converted. Why would you do this to me?
Okay? So for most of our English, and there's an interesting keyword there, most, for most of our English metric conversion systems, we hold them at 3 sig figs. Why? Because when we run most of our calculations in this class, how many sig figs do we expect? 3. So as a general blanket statement for the sake of this class, as long as your answer has 3 sig figs, you're in a pretty good boat. Right? If you start using more than that or less than that as far as sig figs, you better have a dang good reason for it. Okay, so first Suf and then that.
So are these like theoretically exact figures? Is that somewhere like time you have?
Okay? So the time one, it's seconds and seconds, so that one is infinite sig figs. Quarts for volume, quarts to milliliters, that is not an exact conversion. Okay, that has 3 significant figures. If my measurement or my calculation requires 5 sig figs, what do I have to do? How do I add 2 more sig figs to that?
0.00.
I have to look them up. I have to look up what the exact sig figs are for that conversion. Right? So I wouldn't be able to use this conversion factor. I literally have to go out into the internet and find somebody that actually did the conversion with more significant figures. Right? That sucks. That's why you don't have to do it. Okay? If we look at pounds, 1 pound to 454 grams.
That's 1 to 3.
That is also 3 sig figs. So the textbook did a bad job. They should be including it as 1.00. Okay? But they are defining that 1 to be infinite sig figs, and the other one is the other one. Okay, that is also a 3 significant figure. 1 inch equals 2.54 centimeters. I did kind of rush through it and was talking at the same time, so maybe you didn't actually see me do it. Anybody see me do anything interesting on the screen?
You erased.
I erased like the fine print.
Oh.
And what does the fine print say?
Something, the last line, redefines 1 inch.
However, the U.S. Bureau of Weights and Measures has redefined 1 inch as exactly 2.54 centimeters, meaning how many sig figs in 1 inch to 2.54 centimeters?
Infinite.
It's infinite. Because it has been defined. Why did they define that one and none of the others? Probably because the length measurement gets used a lot more across cultures, okay, or across unit systems. And so they had to go through and say, well, actually, we're just going to define this so that we don't have to worry about it anymore. Okay? Even that does have some issues, a la the question underneath. But I see a couple questions first. Suf, what do you got?
Do they have like, you know how like time doesn't lock into that clock? Is it like somewhere it's like 1 yard? It's like
Yes, exactly right. So for the English system, I believe it's in Colorado at the National Institute for Standards in Time. I don't know what T is. It's NIST, N-I-S-T. I believe they're the ones that have it under lock and key, and yes, it is heavily guarded. And it's just a bolt that is temperature and pressure controlled, and what it has in it is a piece of metal that is exactly 1 pound.
Where is that in Colorado?
I don't know where it is in Colorado. I wouldn't be surprised if it's in a bunker behind some heavily guarded facilities. Okay? And then I believe France has the one for the metric system.
So what if you're gonna need to hire some people to go in there?
So you could hire someone to go in there and change it, which would be great, because that would then wreak havoc on this entire system, and everybody after you would have to relearn a whole new system. Yeah, wouldn't that be awesome? Okay. So yes, it is under lock and key. Maddie?
My question is, why did it change from English? I'm so confused.
Why did we define it as 1 inch, the 1 being on the English side and the metric getting the number? Is that what you're saying?
I don't know. I'm always 2 weeks behind on chemistry, so. My way of walking. Damn, by the way. Ouch.
Because pretty much the rest of the world uses metric. America is one of the few that uses.
I would actually venture to guess that if we went to France and looked at their textbook, they're going to say 1 centimeter equals point whatever it is, 49 inches.
It's actually interesting when you brought up the textbook in 1 inch and 1 pound and treating those as infinite, that actually creates a power dynamic within the conversion, because it's saying the 2.54, that's not exact or infinite. Ours, the English version, that's the one that is more pure, more measured. It's like there's a sociocultural dynamic there. It's really interesting.
It's nasty.
That's
Is it okay if I ask questions about the practice now?
The practice, like the question underneath?
Yeah.
Okay. Yes and no. Yes, it is okay to ask, because what we're now going to do is spend 2 minutes to solve that. Do the practice underneath. We have a couple things to address here. The first thing to address is there's actually multiple ways to go through and solve this. Okay? And multiple ways that match my method. Okay? My method, the dimensional analysis method we've been talking about. There are other ways to go through and solve this where you may be using an algorithm that you've done in the past for how you can set up conversions. Okay? So I think I saw something along these yards.
Can I just say that 1 yard equals 0.914 meters is completely and utterly useless?
No.
Nope,
Because you go
you can't.
centimeters.
It's absolutely useful. Okay, so I've seen this method show up yards, and just because you said that, we could then go through and convert to meters. Okay, and that conversion would be times 0.914 meters. Okay, so what you've done is you've taken the process that I've told you how to do, and you're overlaying your internal calculation behind it, and you're saying all I have to do is multiply that number. When you're right, great, fantastic, it worked. But what happened if instead of multiplying, you should have divided?
Well, you're in trouble.
Then your whole thing's out of whack. You might be, well, at least that answer won't show up as a multiple choice. It absolutely will. Okay? All of the possible permutations, as much as I can possibly fit into 5 answer choices, show up. Okay? So you can't just start saying, well, I have to multiply numbers through. Okay? The next part that I want to address on that, I do have up on that board to our left. Okay, but for those people potentially my left, That would be my right, your left, so I was right the first time. Okay? And we've kind of had this conversation before. 2 plus 2 equals 4. What does 4 plus 5 equal? 9. Okay? Does everybody understand that work? Yeah. Okay? And agree that 9 is your answer.
It's a trap.
It's a trap. It absolutely is a trap. Okay? What does inequality mean? Equals. So 2 plus 2 equals 9. No. What you've written there is a run-on sentence. In English, you can't do that. In mathematics, some teachers flip out over that kind of process and mark you entirely wrong all the way through it. Okay? I don't remember when I shifted. I may have recognized what people were attempting to do with that and didn't take off points for that kind of calculation in the past. I still don't take off points for it because I understand what you're trying to do. Okay? But you will encounter teachers that will subtract all of your points. If you want to do something like this of repeated calculations, okay, break it into the repeated calculations. This is 2 plus 2 equals 4, and then 4 plus 5 equals 9. You now have 2 separate sentences. That's now fair game. You're okay. Don't string together your sentences, okay, because were you mumbling writing systems?
Visual design.
Visual design. Separating that out. Okay? The next part, okay, because I saw a bunch of people go through and solve this, you guys should all be able to tell me the answer in centimeters. The answer is 10,968 centimeters. Does everybody agree with that?
I got something.
What did you get?
10,972.
Oh, and we have a confirmation. Who's right?
Didn't anybody get 968? Aside from Robbie?
Okay. A couple people got 10,968. Okay. The first statement that no one's going to like, you're both wrong.
I got 1,002 or I can't even, I don't do math.
If you got 1,000, you're definitely
Yeah,
wrong.
I know.
Okay. If we try to set up this conversion, what are we doing? What do we want for an answer? Centimeters. What did we start with? 120 yards. So what we could go through and do is I want to get rid of yards and I want centimeters. Does that conversion exist? At least in the given information. No. So what do you have to do? You got to convert yards into something. Robbie's saying convert it into meters. What did you convert it into? So I could do feet or meters. Why could I do either one? Both of those conversion factors are there. I wonder why I gave you both to cause this exact issue to appear. We're dealing with a conversion between English and metric. It's not consistent depending on which conversion path you go through to take. And you'll get an error in the exact value at the end. Okay? I don't remember which one's which. Centimeters? Who said centimeters? Sorry, 68. Okay, that was you. You went yards to meters then?
Yes.
As your first step? Who said the other one?
Me.
You went yards to feet. Okay? Go through and solve it both ways. Okay? And you will find that those numbers are possible answers in your calculator. And yet, I said they were both wrong. Why are they wrong? Couldn't tell me. Okay, I'll give you a hint. How many significant figures in your starting given information?
3.
Try again. 2.
2.
1 and 2. How many sig figs in both of the answers you gave me? 5. Those need to get reported to?
The thousands place.
2 sig figs, which means I can only go to the thousands place. Since that number is larger than 5, I can add 1. So the answer that I get would be 11,000. Centimeters. Okay? If we want to be extra clear to make sure that those zeros are not significant figures, we could convert this into scientific notation. 1.1 times 10 to the 4 centimeters. Why positive? Because that number is large. Okay? Those zeros should not be interpreted as significant figures because we don't have a decimal point. Okay? Make sense?
So you're both right.
So you were both wrong.
Okay, until we were right.
Until you address significant figures. When do you have to worry about significant figures? All the time. Whenever you run a calculation, you need to be worried about significant figures. When we go through and look at your answers came in at 5 sig figs. We gave you a little rule of thumb. What was that rule of thumb?
When you multiply, you match the dollar.
3 sig figs. Okay, we said that on this slide, in fact. I said 3 sig figs. Okay? When we look here, we're reporting to 3 sig figs. Why am I not allowed to report 3 sig figs? Because the question sets me up for 2 sig figs. Okay? So as your blanket statement, you should go to 3 sig figs. Okay? Just as I'm just going to go there. Okay? To change out of 3 sig figs, you need to have a reason to do so. Okay? On a multiple choice test, what is your reason to do so?
There's only 2 in the question.
If you looked at your multiple choice answers, and this is where this one gets fun.
You would have all of them.
Yeah, you're gonna be mean about
If that's right.
What is the difference between those 3 answers?
it. They didn't use sig figs.
Sig figs. So when you look at your answer choices should send up a giant freaking flag saying sig figs is important, because you should look at all of them and be like, whoa, that number is different, but it's only different because of significant figures. That should be just enough pause for you to go back and be like, yeah, I got to watch out for that. Okay? If instead it had been, and I don't know all the wrong permutations of this, if we'd seen 10, 9, 6, 8, let's just say 12,000, let's say 9,832, and 2, 6, 4. I don't know, I just picked a bunch of numbers. Do we need to be worried about sig figs?
Yes.
No, always.
Does 10,968 ever round to 12,000? No. Do I need to worry about sig figs? No. Okay. So the answer choices can give you a hint on whether or not you should be looking at sig figs. Okay. So over the weekend, you should be working on balancing reactions. You need to be evaluating oxidation states because that is going to show up on the exam. We won't balance redox reactions on the exam. Okay. So there are some slides on half reactions. Don't worry about half reactions. So you need to be able to recognize your chemical equations. You need to be able to balance your chemical equations. You need to be able to predict single replacement and double replacement reactions. That's still going to happen. Okay? And then we need to do conversions. Okay? That's not going to get us through all the remaining slides even on, Tuesday. Okay? Our exam is on Thursday, so some content is going to be pulled back. I won't know exactly until Tuesday rolls around. Probably what's going to happen is we'll have some extra questions on there that I'll make extra credit. Okay? As far as chapters, 12, 6, 7, and a little bit of 17. Like the first section of 17. Might even be the first 2. Okay? So start working on that. Ideally, you have the practice exam done tomorrow. Tomorrow.